Okay, Algebra 2, we started yesterday, we started problems on like the work problems and like the mixture problems and stuff, and that was a little bit intimidating, so we're going to back off a little ways, and I'm just going to go and do the first couple of examples in section 9.6, and then we will go back to that sheet, okay, and see if it makes it a little bit more clear. But I'm only going to do about half of these examples today. There's 4 of them that I want to do. And so we're going to do example 1, and I'm changing example 2. I want it to look like this, but I'll have you fill that in when we get to it. We're going to do this check right here, and then we're going to do this mixture problem, okay? And then that's all the further we're going to get today, and then I'll give you a little bit of homework afterward. But we are solving rational equations, and then we'll get to inequalities later, but rational equations mostly, and they look like this, okay? So you have like fractions that you're going to end up, solving for and setting equal to and that type of thing, okay? So we are still, just like before, we are adding and subtracting rational expressions, and so ultimately we're going to end up having to find a common denominator with all of this, okay? So the difference here is that we have 3 pieces, and we need to find a common denominator for all 3, okay? Now, this 12 and this 48, those are values that are not trapped with another term, but this x minus 4 is trapped, okay? So I need to treat those as like independent pieces, okay? So what I can do is when I'm trying to find a common denominator, first things first, I'm going to not look at their work because their work drives me crazy, okay? I'm going to write my 3 pieces over here. I'm going to use this like this. I'm going to write my 3 pieces, so I have this plus this equals this, okay? And just set up just like that. 1 fraction plus another fraction equals the 3rd fraction. And then from there, I have to decide what my denominator is going to be. So looking at the stuff that is like not trapped, like this is not trapped and this is not trapped, let's come up with a number that 12 and 48 both go into. Well, the nice thing is 12 goes into 48, so I can just use 48 as that number. Like my common denominator of 12 and 48 would be 48. So I'm going to use 48. And I'm going to use 48, and I'm going to use 48, okay? All right, then x minus 4 is trapped, so I have to treat that independent from the other 2. So I need an x minus 4 in my equation. X minus 4, he's got to go in my denominator. X minus 4, x minus 4, x minus 4. Okay, so when I look at each of these pieces individually, I can say, does 12 fit into there? Yeah, it goes into the 48. Does x minus 4 fit into there? Yeah, it does because I have x minus 4. Does 48 fit into there? Yep, you bet. So I know that my denominator is correct, and now I just go back through and I start multiplying by what they don't have. So I've got 7, 9, and 55. 7, 9, and 55. Okay, and then I need to compare, and I need to multiply by what they're missing, right? Okay, so this first one might be a little tricky. I have 12 on the bottom, and I need it to become 48 and x minus 4. So I need the 12 to be multiplied by 4, but then I'm also missing the x minus 4. Okay, so 12 in comparison to 48, he needs to be multiplied by 4, but then we're missing x minus 4 also. Okay, the 9, if I go to the next step, 9 has x minus 4 on the bottom, but he does not have the 48. Okay, so we've got to multiply 9 by 48. And then the last one, 55, he has the 48, but he's missing the x minus 4. Okay, so x minus 4 needs to be added to the 55, okay? Now, at this point, this is my favorite step in the process. Because I have this equal sign, I have like 2, like a left and a right side, and they both have a denominator of 48 times x minus 4, so I get to cross that off and not look at the denominator anymore, and that is it, okay? Now I just have to deal with the top, okay? So I'm going to go through and I'm going to get rid of some of this parentheses. 7 and 4 multiplied together is 28, and now I'm going to distribute 28 through. So 28 times x is 28x. 28 times 4 is 112. So this is minus 112, okay? Then plus 9 times 48 is 432. Let me check that again. It's 432 equals, okay, I'm going to distribute the 55 through, so this is 55x minus, I think that's like 220 or something. 55 times 4 is 220, yep. okay? And now I just have a very easy algebra problem that I can do, okay? Negative 112 and 432, those are on the same side of the equal sign, so I'm going to combine them, like negative 112 plus 432 is 320. Okay, now I'm going to do some things. I'm going to subtract this 28 to the other side, 28x minus 28x. So I've got 320 is equal to 55 minus 28, and that is 27x minus 220, okay? I'm going to add the 220 over, and that ends up being 27x equals 540. And if I divide by 27, that is going to be, I think, 20. X is going to be 20, okay? So I've solved for that. So as soon as you get your common denominator and, you know, cross your denominator off, it's just a straightforward, like, algebra 1 problem from there, okay? And there we go. Let's do some more and let's see what else we have. Example 2. Get rid of this example 2. That's really disgusting to begin with. And I want to start us off with something a little bit easier. So here is what I want you to write on. We're on example 2 on that page. I'm going to go off to the left side over here, okay? So what I want you to put is 9 over x minus 7 minus, we're going to do a subtraction problem now, 7 over x minus 6 is equal to 13 over, and this is a trinomial, x squared minus 13x plus 42, okay? All right, the first thing I need to do, and some of you guys maybe have done it already, change this to a plus and change the 7 to a minus, okay? I always do that to begin with because then you forget about the minus and then he turns to a plus and you get the answer wrong. So that's the first thing. The second thing is I go through each denominator and I try to break them down. So x minus 7, he's simplified. X minus 6, he's simplified. There's nothing I can do with those two. But this guy is a simple trinomial. And I want to know if I multiply two numbers to get 42, and when I add them, give me negative 13. And just a little hint, it's usually these two, or has something to do with those two, right? So if I take x minus 7 and x minus 6, 7 times 6 is 42, but negative 7 and negative 6 is negative 13. So that's how that breaks down. So when I go to try to find my common denominator, okay, I'm going to do my 3 pieces. So I've got this guy plus this guy equals this guy, right? Trying to find my common denominator, I know that I need to include x minus 7. Oop. I know, so I'm going to do x minus 7, x minus 7, x minus 7. I know that I need to include x minus 6, x minus 6, x minus 6. And then I go through this piece. I know I have to include x minus 7. Oh, wait, I already have one. And I know I have to include an x minus 6. Oh, wait, I already have one. Okay, so then I'm going to write my tops. So 9, negative 7, and 13. And then I'm just going to multiply by what they're missing. Okay, so what do they need? This 9 has an x minus 7, but he's missing the x minus 6. This 7 has an x minus 6, but he's missing the x minus 7. And 13, he has both of the pieces, right? So what do we multiply by? You don't have to multiply by anything, or you can just put a 1 there. And that's what we're going to multiply him by. Okay, favorite part, cancel the bottoms because they're all the same. And now I'm going to distribute. 9 times x is 9x minus, that becomes 54. Then I distribute my 7. Now, if I would not have changed this minus to a plus and put my minus here, I would forget to distribute the negative with the 7, right? That becomes negative 7x plus 49. So if I didn't put the negative up there, I would forget that this becomes a positive 49 instead of a negative 49. So you got to be really careful. Equals 13. Okay. Now, before I start moving stuff, 9x and minus 7x, that's on the same side of the equal sign, right? So that just becomes 2x when I combine them. Negative 54 and positive 49, that becomes negative 5 equals 13. And then all I have to do is just do the basic algebra. So add the 5 over, and I get 2x equals 18, and divide by 2, and x is 9. And if that was too fast, you can pause or go back through that again. Okay, it starts off looking like a really super ugly problem, but as soon as you get that denominator crossed off, it's very, very easy from there, okay? All right, let's do, before we do our work problem, let's do this check right here, okay, because it is kind of good. And first things first, Okay, I really wanted to go through this check for this reason, okay? Minus. That minus changes to a plus, but because there are 3 pieces up here, the x squared isn't the only thing that changes sign. That becomes negative x squared, but this becomes plus 7x plus 4. Okay, so you've got to distribute the negative for all of these pieces, all right? And that's one of the reasons why I really wanted to do this problem, okay? All right, x minus 4 is one of the denominators. I can't do anything with that. X plus 4, I can't do anything with that, but this guy is a difference of squares. And if I break him down, the square root and the square root of x squared is x. Square root of 16 is 4. One of them's plus, one of them's minus. So it just so happens that this and this become that denominator. How convenient, right? Okay, so I'm going to do my work up here. I've got this guy plus this guy equals this guy. Okay, and let's see what we get. All right, I know in my denominator I need an x minus 4. So I'm going to put x minus 4 there. I need that to go for all 3 pieces. Now I know that like Lauren Komecher's sitting there like, do we have to write this down? If it's just going to cross out, I don't care. Don't write it down. But just make sure that you don't like forget a part, okay? So if you don't want to if you want to skip steps and not have to write this bottom part down because you know it's going to cancel off, that's fine. I don't care, okay? Just don't make a mistake. So x plus 4 I know is my other piece that I need for my denominator, and he's good to go, okay? So now, girls. Shh. Okay, I've got my tops are 3x. Ugh, this is negative x squared plus 7x plus 4. And this one is 5. Okay, so here I have what I need to multiply by what he needs. Okay, so this 3x, he had an x minus 4 below him, so he needs the x plus 4. This guy, the really long, ugly thing, thank goodness, he has everything below him, so he doesn't need anything, so I'm just going to put a 1 there. And then the 5 had an x plus 4, so he needs an x minus 4, okay? Favorite part, cross everything off of the bottom, and then I'm going to distribute through, okay? So I've got 3x squared plus 12x, okay? Then this guy, because he's just getting multiplied by 1, I'm just going to recopy him down, minus x squared plus 7x plus 4, and then he's equal to, if I distribute that 5x through, 5x minus 20. Oh my heavens. Okay, let's see what we've got going on here. I'm going to combine stuff if I can. So this guy and this guy are on the same side. I can put those together. 3x squared minus x squared is 2x squared. Then I've got 12x plus 7x. I can put those two together. That is 19x plus 4 equals 5x minus 20. Okay. Now, normally, I try to get the x's on one side and the numbers on the other, but I have this x squared here. So that changes things a little bit, and this is a trinomial. I'm going to take this stuff and I'm going to shove it over here also, okay? So I'm going to make everything on one side of the equal sign. I'm going to subtract this 5x and subtract this 5x, okay? Then I'm going to add this 20 and add this 20 here, and now I have equal to 0 on that side. Okay, let's just put stuff together. So I've got 2x squared. This is going to become 14x, and this becomes 24. Okay, now what? Now what? Well, if I want to make this a little bit easier on myself, I can divide everything by 2 before I solve this, okay? So I have x squared plus 7x plus 12 equals 0. And now, finally, I just have to break this down as a simple trinomial again. So I want to multiply to get 12 and add to get 7. And that is going to be x plus 5 and x plus 2. Okay, but one more thing. If x plus 5 is equal to 0, then x equals negative 5. And if x plus 2 is equal to 0, x equals negative 2. Okay? All right, so kind of a long process on that one just because we ended up with something really kind of icky at the end and we had to break it down and solve, okay? But, you know, that's a thing. That can happen, okay? Those are my 2 things there. All right, one more thing. Mixture problem. Oh, yeah, mixture problem. Here we go. All right, rubbing alcohol. When we did mixture problem before, let's write down our equation. We had 2 things that we're adding together. So we've got this guy plus this guy equals my final solution, right? And usually we did amount, like amount times the concentration, and amount times the concentration, amount times the concentration. So they're going to probably give us like, there's this much alcohol in whatever, like this much rubbing alcohol in whatever, okay? And they're going to give us amounts and concentrations of that alcohol, that stuff, okay? We're adding them together to figure out our final solution. All right. Okay, rubbing alcohol, a commonly used first aid antiseptic, typically contains 70% isopropyl alcohol. Suppose you are adding 50% isopropyl alcohol liquid to 200 milliliters of a liquid that is 91% alcohol. Woo! 91% alcohol. That probably is going to burn a little bit if you put it on a boo-boo, right? Not going to be fun. So that's why we're diluting it down. We're adding the 50% to dilute it down to 70%. Okay, so here's what I know. I know that we are starting with 91%. So I'm going to call that 0.91 concentration. We are adding to that a 50% concentration. And at the end, that's going to give me a 70% concentration. So I'm going to go 0.70. Hey, Layla. Layla Bean. Okay, so that's what I have going on here. Now I need to know amounts. So the only amount that it gives me is the 200 milliliters. All right, and that's what I'm starting with. So that's my 91% solution. I have 200 milliliters. Now I don't know how much I'm adding, so I'm going to call that X, and then my final amount, I don't know what that would be either, because if, like, let's say I'm adding 50 milliliters, right? My final solution would be 250, right? Whatever that would be. Or if I'm adding, let's say, 100, my final solution would be 300. But I don't know what it is, what X is, so I'm going to call it just 200 plus X is what I've got, okay? And then I just do some math. So 200 times 0.91 is going to be 182, I believe. Okay, plus this is going to be 0.5x. I'm just going to put the 0.5 in front of the x. And then equals, I'm going to distribute my 70 through. Okay, so 70% of 200 is going to be, I think, 140. Plus 70% of x is 0.7x. Okay, and now I just have four terms, 1, 2, 3, 4. And I'm going to combine stuff. Okay, so I'm going to subtract my 0.5x, and you can subtract the 140 at the same time. I'm going to do two separate steps, but there's that. Plus 0.7x minus 0.5x is 0.2x, and then I'm going to subtract my 140. So if you wanted to skip steps and do that all at one shot, that is totally fine. Okay, but 182 minus 140 is 42, and then I'm going to divide by 0.2. That is 210, I believe. Right, 42 divided by 2 is 21, but I have to add a 0, right? It would be like 420 divided by 2, so 210, whatever. 210 milliliters, that's a lot to be able to dilute it down. I had 200 milliliters to begin with, so like I have to add more than half of the solution to get it from 91% down to 70%. That's a lot to dilute it down. Okay, so 210 milliliters, mLs. Okay, yeah, so it's diluted down enough so that it doesn't quite burn so bad. All right, so again, that was a mixture problem. Those ones I kind of like. I think they're kind of fun. They're set up that way every time. Amount times concentration, amount, concentration, amount, concentration. Okay, so hopefully that was not so bad. All right, we are going to wait, and we will do some more of the distance problems and some of the other work problems tomorrow. Not tomorrow, Tuesday. We'll look more at that, but here is the homework problems that I want you to do, just these. 4, 6, 10, 12, and 16. And that's page 501. 4, 6, 10, 12, 16, okay? 4, 6, 10, 12 should be similar to the first three that we did, and then you have one work problem, okay? So 5 problems for homework, that is all. Have a happy Easter. Goodbye.